Hello students, welcome to this session on electromagnetic fields. We will continue our examples which we started on Coulombs law and charge densities. So we are clubbing them together and we are going to solve the examples related to densities, Coulombs law, and wherever applicable we will also see the examples on electric field intensity. So let us begin with the first example. This example 2.7, and it says that there are three equal point charges of 3 microcoulomb. They are located in free space. One is at origin, another one is on x-axis with distance 2, and third one is on y-axis with distance 2. We have to find out the net force on some charge Q4 which is present where x is equal to 2 and y is equal to 2. So first of all we can try to imagine the setup of this diagram. So let us try to draw it. Say we will consider one z axis, but in this example z points are not given. Still for reference we will keep it. So this is our z axis. And we will extend say one y-axis like this. Now imagination is important here, and then one axis will consider which is coming towards us, that is x-axis. So these are three axes, so we will write down their names. So these three axes, let us write down about them here. So we have, say this is z axis, this one y axis, and this one is x axis. So on this we have to locate the given points. First one is at 0 0 0, that means at the origin. At the origin first charge is present. Let us call it as Q1. So here at the origin we have say Q1. Then Q2 is at 2, 0, 0. That means it is on x-axis where distance is 2. So say this is x-axis 1 and 2. So second charge is present here at Q2. Then third charge we can see here, it is on 0, 2, 0. That means it is on y-axis. Only y component is given. So we will move on y-axis. So here you can see, say this y-axis, say 1 and 2. At this place the charge Q3 is placed. Now charge Q4 is placed where x component and y component are 2, 2. So let us see the solution. Here we can see that we have charge Q1 equal to charge Q2 equal to charge Q3, and its value is 2 microcoulomb. So this is our say charge Q. These three are same, but the fourth one Q4 is equal to 5 microcoulomb. So we have to find out the destination and source points. So for source points and destination points, say considering R1 points are at origin. So it is 0, 0, 0. These are the points at origin. Then second we have R2. R2 points are on x-axis, the value is 2, and other two axis values are 0. Then we have R3. R3 is equal to x is 0. Then we have y as 2, and then z as 0. So for the 0 we get everything there is no value. But here if we convert them in with direction, here we get 2x cap, and this one we can write as 2ay cap. So for next, so this is R3. So R4 we can write, R4 points are 2, 2, 0. That means we have 2ax cap plus 2ay cap. So this is R4. Then if we calculate the force from point 1 to point 4, so what we will do, we have to subtract destination points minus source points. So R4 minus R1. So this is our R4, and here we have R1. R1 is anyway 0. So R14 will be equal to same value, 2ax cap plus 2ay cap. So these values we will get. Now next one we will calculate, say, the force from point 2 to point 4, say R42. Again we will do same, destination points minus source point. So we will get it as R4 is 2ax cap plus 2ay cap minus R2 is 2ax cap. So here we will write 2ax cap. So 2x cap will get cancelled. So we will get it as 2ay cap. So this is our R42. Now similar way we can find out the force from point 3 to 4. Say this is R equal to point R4 to 3. So destination minus source points. So R4 is 2ax cap plus 2ay cap. Now we have to minus the components of R3, that is nothing but 2ay cap. So in this case this ay will get cancelled, so we will get 2ax cap. Okay, now let us see the magnitude for force from point 1 to 4. So magnitude we calculate as square root. So 2 square 4 plus 2 square 4. So this value is, say, root 8, and if we calculate it, it is around 2.828. So we will get this value. So this is R41. Similarly, say we will get R42. This value if we calculate, we will get 2, and R43 magnitude will be equal to 2. Now net force if we want to calculate on Q4, that will be total of F41 plus F42 plus F43 plus F. That's it. These three forces total we have to take. So by using Coulombs law we can find out these values. So say from Coulombs law, force between say point 1 and 4 will be given as, say, Q into Q4 divided by 4 pi epsilon naught r square into a 421 cap. So a 41 cap is nothing but 2ax cap plus 2ay cap divided by the magnitude. Magnitude is 2.828. So if we keep this value here, we know the charges, so we can calculate the force, and similar way we can find out the value of say force between 0.2 and 4. What we will get it? That is q4. This is same. Then 4 pi epsilon naught r square. Now this r square will be from 2 to 4, that we have to consider, and here ar cap. AR cap in this case will be AR cap, that is from the same point, from 2 to 4. So if we calculate it, we get the answer. So AR 4 to 2, if we check it, this is nothing but equal to AY cap. So similar way we can find out these three forces, and we have to take addition to find out the overall force. So say overall force, we can say Q4 is common for all, divided by 4 pi epsilon naught, this is constant. Then we have say A41 by R41 plus A42 by R42 plus A43 cap by R43. So we'll keep the values. We already know the value Q and Q4. So say it is 2 into 10 to the power minus 6 into Q4 is 5 into 10 to the power minus 6. If we calculate 1 upon 4 pi epsilon naught, we get 9 into 10 to the power 9. Now these values we have inside first one. This one is nothing but 2ax cap plus 2ay cap divided by 2.824, then plus next one we got ay cap by 4. Similar way third one is ax cap divided by 4. So you practice this calculation on Calc. I will write the answer here. So net force due to all these three charges on the Q4 will be equal to 30.45 AX plus AY newtons. So there is answer for this example. So with this we will stop here. Next session we will see next example based on the same Coulomb's law and different charge densities. Thank you. Have a good day.